Yep. Thanks a lot. Yes, like he said, I wear multiple hats tonight. I've left my magician hat home. There's going to be a different magician here tonight after our session, so don't leave. We're going to have another digital magician. By the way, you guys people saw my stuff yesterday? Yeah? So tonight, thanks. So tonight I just wanted to do a different take on, I wanted to do more technical deep dive on augmented reality beyond the screens. And when I really say beyond the screens, there are a lot of buzzwords or technologies that kind of complement augmented reality. Augmented reality, as most people are either talking about it or understanding about it. And one point in time, I thought all it was really computer vision, right? Because we're talking about these head-mounted displays or phones and looking at real world and seeing digital objects on top of that. So I really wanted to drive the point today, and I'm doing a research on voice user interface. So I've been playing with IoT, with phones, and really thinking about how to go into really AI-based voice user interface, where you can really have a conversation with these agents. So that's my area, and I want to see how that fits with augmented reality. I came across some really good examples. I've been prototyping my own, and what I found, there is this thing called augmented audio. And actually, I can explain you more, but I'll remind you, if you guys saw the example this morning, how many people saw the example of soundscape this morning? Yeah? You guys liked it? Cool. So that is exactly what I was going to kind of hint on. Geo-aware, it could be beacons, IoT sensors, or the hologram itself is aware of the location. It tracks position, and it has audio inside of it, so you can listen to it. So why audio? You know, like when we talk about reality, we have different senses, right? Physical senses through which we take the perception, through which we perceive the reality. Now the brain is what actually processes all of this, right? We don't see these images, these are electrical signals, but the brain makes it up based on memory and a lot of different things. So a huge part of the brain is devoted to the visual cortex, or just the vision, processing the vision. And there's part of the brain devoted to motor skills, part of the brain devoted to the spatial navigation, the 3D space. But there's also a small part of the brain. And if you think a brain in terms of a computer processor, think of a multi-threaded processor where there are multiple processes running on multiple threads. So you can do parallel processing, and they don't have to be all at the same time, lock the machine up. They can happen at different time using different part of the operating system. So we can complement what we are seeing, the augmented vision stuff, with augmented audio, and the brain can process both of them. Just like when you're driving and you can listen to music and have a conversation, think about it like that. So I really wanted to talk about augmented audio and mention voice user interface. My passion lies in UI and UX. So I've looked at a lot of different types of user interface that have evolved in the last kind of 2 decades, and those stuff that's coming out in the future. If you're interested in that, read up documentation by Microsoft Research on this thing called natural user interface. And the one today I'm going to talk about is obviously this thing. And this is two-way voice user interface. So it's not just you're listening to music, but you're also having a conversation. More than, and when we talk about voice user interface or VUI, it's more than just saying commands and activating the system. It's actually having a conversation. So you can layer one more axis on this, and which let's call it artificial intelligence. And we're making the machines or these agents more and more intelligence through different technologies, right? Such as machine learning, so that they can have a more natural conversation. The interface can become more natural. And there have been innovations in gesture, mood, gaze. I don't know if you remember which phone company was it, where it tracks your pupil, and if you look down, it automatically scrolls the page or content up and down. So there's a lot of, and especially virtual reality headsets that track your eye movement. Next level would be mood. And right now, this year, I believe, is the year of voice, really voice kind of shining through Alexa, Google Home, your mobile devices, and more voice-enabled technologies coming through. So there's one more reason why I want to stay away from adding more content just in front of our eyes. Like I get tired, I'm looking at my phone when I'm not in the office, or I'm reading a book on Kindle, and I'm looking at screens all day, and my eyes get tired. There is also a research, if you want to read a paper, you can Google the term blue light retinal toxicity, and it talks about how they found, like after some time, exposure to LEDs, which have blue light, that the eyes, the retina, starts getting damaged, and it can lead to various kind of eye diseases. So, and there's computer vision syndrome, which, where you can have all kind of side effects. So I get tired of just looking at screens all day. So I really want to interact with the technology beyond something just by other than looking at it. And there is another big reason. Think of the millions of users who are what I call visually impaired. So I also do a talk on accessibility and mobile accessibility. And we always talk about, people not just who are blind, but people who are low vision, who are due to old age or brain impairment, they can't see or process things. And now we're putting these high fidelity graphics and making them read and interact with it, and otherwise the stuff doesn't work. There should be another way, and there is. And there's always going to be extreme use cases. So have you guys seen this video on YouTube? It's called Hyper Reality. People seen it? Few people? Okay, I'll play a little bit of it, and I will explain you. So those who haven't seen it, you might get overwhelmed with this. You might have a visceral feeling about it, but there is a lot we can learn from this. Just like if you go watch a sci-fi movie and you see the futuristic user interfaces, I geek out about that, and I try to understand like how, they did it in After Effects, but how can we really make it happen? So this video, this guy made this movie, but really there are a lot of things right now today which are possible. I'll kind of break it down, but I'll let the movie play. How do we play this movie? Can you play, please?
Nice. Great.
Más tarde, apúrate si quieres una buena calificación.
Voy lo más rápido que puedo.
¿Has pensado en correr? Es saludable y eficiente.
Seguro que no hay más trabajos disponibles. Yo estudié para ser profesora y estoy haciendo mercados.
Y además puedes quedarte con los puntos de fidelización. Eres una monkey afortunada. Tienes que confiar en la aplicación. ¿Te sientes inspirada? Gracias.
So what you're seeing, okay. Hear the audio. Can you have the audio? Okay. She invoked Google, and she did not type the query. She said a voice command.
¿Para dónde
And
voy?
it's showing gesture recognition also.
No. Puedo volver a empezar.
And she's saying, and it's asking, and it's very sarcastic in a way. We lose our identity in the future. It's kind of scary, but pay attention to the sounds, and they're geolocation aware. So right now she's in the bus. She can hear the people around. There's music in the background. There is noise of the city. And you'll see as she comes out of the bus, the music will change. The music will stop. And now she's in the cityscape downtown. So the music automatically stops. Now think of the example we saw this morning, soundscape. If the guy's walking, and if you're here, you can hear something else, or you hear. Now, there are multiple use cases for that, and that's augmented audio. You can have a walking tour of MIT Media Lab. You don't have to have anybody here. If you're here, you can walk around, hear the history, who did what research, or what's going on here in front of you. They can be geo-tagged. In this example, I don't think we have time to play it again, but I would really break down. There is a lot of technology. There is the virtual character she's speaking with. Now, right now, Facebook, a lot of these guys are they're talking about bots. And you're typing the messages, and you're talking to a virtual agent, basically. That's exactly the same thing. It looks real, but it's photoreal. And it's computer generated. So it's talking to a customer agent, but he's so smart that you can't tell. And he's answering your question. So you don't care, because you call the customer service, in this case was his guru or something. One more example, this is more useful example. This was the extreme. I'll say about point. One more thing about vision-based augmented reality. The problem in visual design with that is the placement of the graphic. So first of all, there are a lot of problems. So in daylight, when you look at either HoloLens, the 3D graphic, the quality, it's not very good. It's only in certain ambience. And then the placing of the graphic, so it overlaps. In this case, she goes to a supermarket, and now she's seeing all these products. And if you overlap, if you augment digital graphics on top of that, you can't read the product information. So now you have to think about, as a designer, how would you place that information that's contextually relevant and the information that's already around us. I'll show you, can you play the video, please? This is a research project by PhD grad students.
Smartphone and smart glasses. We then try to compare the difference they have on user experience and usability to find out which of the two devices gives a better experience as a museum guide.
Pay attention to the audio part of it.
For this, we developed an augmented reality museum guide, which includes a pointer mechanism that directs the user's attention.
Jan Utzon had created an art collection, mainly of prints by a number of major French artists in the 20th century.
So there is no marker, it did computer vision. It recognizes the image and it outlined it and it's telling you about it. Now this is a game in a museum.
Our idea comes as a result of improving
So you can read more about it. I believe the videos will soon be up, and you can play with this application developed by these students at the university. So vision is just one input. Now we can close our eyes and just provide audio, 3D audio, spatial audio, for users who don't need to see. But this is, you're complementing now. Because imagine if it was just vision and you have to tap gestures. It makes it more immersive when we add audio. And there are more senses, like the ones, if you have seen the demo, augmented reality is more than even sound, it's touch. And they have the haptic, it has ultrasound sensors, and it's augmenting your sense of touch, and you're not really touching. It's kind of like if you have the new iPhone or Mac, where it's a thing called force touch. It's augmenting touch. It doesn't really press down, but the brain thinks it goes down. One more example. Can we play this one, please? This is an artistic example. He has created music out of everyday objects. He has augmented the sound you hear every day when you're tapping on something, creating music. It's a regular everyday objects. They've amplified the sound and they've augmented effects to it. So you can create music with things around you. And you can buy his product. This was also a PhD research project, which then went to a Kickstarter, and now link is in the description. And with that, I just wanted to kind of make my point that, really the user is interacting with the world or the reality around him or her. And it's just more than one sense. The vision, there are other senses that we can augment. And I'm here to talk and evangelize audio or voice interface. Thank you very much.